Okay, we're finally at K-Maps. Yay! Alright, so this equation here, using the methods we've learned so far, I've sort of just broken this down. So we have A naught, B naught, ORed with A, B naught, right? So you can just pull out the A naught, A term, and yeah, trivially you can just write it out like that. Let's fill out the truth table for this equation. So I have the values of A and B filled out already. Let's fill out A naught, B naught. So A naught's true, B naught's true, so this will be 1. Cool. Here it will be a 0, it will be a 0 here too, and here. Cool. And now let's look at this one. So for the first one, A is 0, B naught's 1, so this will be a 0. Here A is 0, B naught is 0, so this will be a 0. Here A is 1, B naught's 1, so this will be a 1. And similarly 0 here. Cool. So what is y? So y is r of these two, right? So if either one of these is true, y will be true. So is either one true here? Yes, it is. Is either one true here? No, it's not. Is one true here? Yes. And here not. Cool. So now that we know what minterms are, let's fill out this little thing here. Oh, little spoiler there. That's okay. So let's find out what the minterms are, shall we? So for the first one, we have midterm 0, right? Because 0 and then 0. Let me pick a different color. So 0 and 0. And if we write that in binary, 0, 0, base 2, that's equal to 0. Cool. Similarly, for this one, we have a 1, 0, min base 2, and that's 2. Cool. So minterms 0 and 2 are the ones that it's, true for. So let's fill out this goofy looking thing here. So this table looking structure is called a K-map. So it has these cells, right? So each of these is a cell, and it can have either a 0 or a 1. These aren't zeros, I'm just drawing circles. Okay, so as you can see, we have a sort of graph-like structure here, right? So let's look at our table. Let's look at our truth table. So we know that for A0, right? A0 and B0, Y is 1. So let's write 1 in this cell here. Cool. Now let's look at this cell on the right here. So we have B0, A1. Let's trace that. So B0, A1 just happens to be 2, right? Now we have B1, A0. So where's B1 and A0? B's 1 here, A 0. So that's a 0. Let's draw the 0. And then here we have A1, B1. For A1, B1, we have output B 0. So that's 0. So we have our table. What do we do with this? Well, we use this to simplify stuff. So prime implicants, as they're called, is what we'll use to simplify this. So notice how there's a row of 1s here, right? So this row of 1s, does that tell you anything? Well, I did not mean to do that Dora pause, by the way. But anyway, so we see that both of these 1s occur when we have b equals 0, regardless of what a is, right? Like a is 0 here and 1 here, but the output's just 1 regardless, right? So we can just say, okay, the output's 1 when b is 0. So b naught. What do we have here? B naught. So it's a lot easier, isn't it, than wrangling all of those Boolean algebra terms all the time, especially for bigger equations. So that's what a prime implicant is. Now let's look at something a bit more complex. For this one, I have our table filled out, and I have this helpful ID field here. So this is just, the binary representation converted to decimal. I just wrote it out so you can, see it visually and like follow along. Cool. So we have our function represented in truth table form here. So let's follow our tried and true method here and fill out this table. So for A0, B0, we have output B0. Cool. For A0, B1, so that's this cell here, we have output 1. For A1, B0, so that's A1, B0, we have 1. For 1, 1, we have 1. Cool. So this time we have 3 ones. How do we group these? Well, can we just make an L like that? Oh, I can't make L's. Can we just do that? Not quite. When you have prime implicants, they always have to be they always have to follow this property here. So they have to be powers of 2, right? Is 2 into 1 a power of 2? Yes, it is. We can just do 2 times 1 time, or that's not a times, it's just a cross, right? 2 times 0. That gives us a 2 into 1 kind of grid there. So let's try and find such a grid. So we have 2 times 1 here, and we have another 2 times 1 grid here, right? So what does this tell us? Well, let's look at the orange one first. So for our orange grid, we have, so when A is 1, right? So A, let's look at our B here. So B was 0 in the first case, and the output's 1. B was 1 in the second case, and the output's 1. So regardless of B, it's just, if A is 1, the output is 1. So let's write that. Cool. Now let's look at our yellow one. I'm going to draw another box. So let's look at the B. Similarly, B is 1, so the output's 1, regardless of what A is doing. Cool. So now we have A and B. So we have these 2 outputs here, right? So what can we do with these prime implicants? We just OR them. So once we get our prime implicants, we just stick an OR in there, and then we just write it out in sum of products form. So here we just have the one variable. We can have multiple variables. Like it can look something like AB plus I don't know, something like all right, B naught C, I guess, something like that. Basically, it can be any sum of products form. So yeah, that gives us our simplified expression. So if we look at this intersection here, we can see that when we plug in A1 and B1, we get 1. So we can verify our solution that way, just visually. And that's a much simpler method, isn't it, than all of this nonsense here. So yeah, that's a K-map.